Hi guys, today we are going to be moving on to Unit 2. This unit is all about algebraic expressions and equations and inequalities. So please make sure you have paper out to take notes because you should be following along, taking notes, so you have all of these examples to reference in the future while we are practicing and moving more in depth. All right, so our essential question for today is how can you simplify an algebraic expression? So that's going to be one of our main focuses for today, and we're going to be talking about three other things. Those three things include identifying terms and like terms. So you should have been introduced to this last year in 6th grade. Simplifying algebraic expressions, also hopefully touched on it in 6th grade last year. And then we're going to tie these back to real life application. So part of this will be kind of a review from last year. Of course, that was a long time ago, so no worries if you don't know or remember. But the only difference is that these are going to be a little bit more challenging in the content. So once we move on, you will see how that is. All right. So the first thing I want to discuss here are something called like terms. So like terms are terms that have the same variable raised to the same power. All right, and I'm going to show you an example of that right here. So the same variable raised to the same power, and real quick, I wanted to find variable. So variable is a letter that represents an unknown value. So whenever you see letters in math, it's because it's an unknown value that we don't know what it is. All right, so like terms are terms that have the same variable raised to the same power, and a variable is a letter that represents an unknown value. And one more thing I want to add is constants are numbers without coefficient or without variables, and those are also like terms. All right, so you should be also following along and writing all of this down. So once again, to reiterate, like terms are terms that have the same variable raised to the same power. A variable is a letter that represents an unknown value, and then constants, which are numbers without variables, are also like terms. So right now with these two examples below, we're just going to go ahead and identify like terms. So when I'm looking at this one right here, I see 9x. Remember, we're going to find something with the same variable, so we're also going to find something else with x. In this case, I see negative x, and those are like terms. When we're moving on to the next one, I see negative 2. That's a constant because it has no variable on it. And I see positive 7. And those are also like terms. So in this case, we're not going to simplify just yet. We will in the next slide. But I could combine the 9x and negative x and the negative 2 and 7 to simplify that expression. All right, now let's identify like terms in this other example. So we have z squared. So z to the second power. So we need to find a like term that also has z to the second power. So this negative 3z squared has the same variable to the same power, right? Those both have z squared. Now, some people make the mistake of counting 5z and z all to be like terms with those, but remember, those are not raised to the same power. So now, at this separate category would be 5z and z, and those two would be like terms since those are both variables raised to the same power. In this case, they don't have a power. All right, so those are all like terms. In this next slide, we're going to work on simplifying those expressions. And I'm just going to write a little bit of info of how to do that. So to simplify an expression, we're going to combine like terms. And basically what we're going to do here is we're going to use our knowledge of adding and subtracting rational numbers. So use your knowledge of adding and subtracting rational numbers. That means we have to take the signs into account. And in this case, we add or subtract the coefficients. And what the coefficients are the numbers in front of the variables. So add or subtract, depending on what the signs are, coefficients. And what a coefficient is a number in front of a variable. And then you keep the variable the same. And I'll show you an example of that right here. All right, so in this case, let's first identify like terms. Remember we did that in the previous slide. So we had 9x and we had negative x. So we're going to know that those are like terms. And then we have negative 2 and positive 7. Those are also like terms because those are constants. So what we want to do is we want to combine our like terms. So here I'm going to take the 9x and the negative x. So this is 9x minus x. And anytime we just have a variable, that's the same thing of having the coefficient of 1 in front of it. So in this case, remember we just subtract coefficients and then we keep, I should have wrote that, keep variables the same. So in this case, we'll just do 9 minus 1 and then plop the x on the end. So 9 minus 1 gives us 8x. And then we want to do the other ones and combine them. We had negative 2 plus 7. Remember back on when we were adding and subtracting integers, in this case, they're different signs. So we're going to subtract and keep the bigger sign. So our answer will be positive, and 7 minus 2 is going to give us 5. So when we combine those, we get 8x, plus 5 as our final answer. And you cannot simplify this anymore because the 5 and the 8x don't have like terms. So that's all we have to do. All right, let's move on to the next example and do the same thing. So first identify those like terms. We have z squared and negative 3z squared. Don't forget the negatives in front because those are let you know if you're adding or subtracting. All right, so we have our like terms here. Since I'm already in blue, I'm gonna go and start here. I have 5z plus z. Remember, if it's just the variable, it's like there's an imaginary 1 in front of that, and you're gonna add the coefficients in this case. So 5 plus 1 is gonna give us 6z. And then we're going to combine those other two like terms. So we have z squared. Remember, that's like 1z squared if you wanted to add that variable in front. Oops. And then in this case, minus 3z squared. So once again, different signs. We have a positive 1 and a negative 3. When we're adding those two, since they're different signs, we're going to keep the bigger sign and subtract. So in this case, our answer is going to be negative. And then 3 minus 1 would give us 2z squared. And then this was positive, so that would be plus. So our final simplification would be negative 2z squared plus 6z. And we can't simplify anymore because those are not like terms. All right, so feel free to rewind if you need an example again, but we're going to move on and have some more. All right, so let's work on this one. First, let's identify like terms. We have 3/4 y, negative 1/2 y, and then we have positive 12 and negative 6. So we identified our like terms, and we're going to have to combine them. So over here, I am going to do 12 and negative 6. Luckily, that one's pretty easy. 12 minus 6 is just going to give us 6. But on the other side, we have some fractions to work with, which can get a little scary sometimes. So we have 3/4 y and minus 1/2 y. So hopefully you know you can't do that because they do not have the same denominators. So in this case, we're going to change the denominators. And what we can do is we can multiply this by 2 by 2 to get us 2/4. And then now we can subtract straight across. 3 minus 2 is 1. And then remember the denominator stays as 4. And so in this case, we are left with 1/4 y. And now we can just combine to get our final answer. We have 1/4 y plus 6. And that is what we are left with. So remember, this relates very closely to the last section that we worked on, to Unit 1, because we're basically applying all of those principles and practicing even more when it comes to adding or subtracting fractions or decimals or rational numbers. All right, some more examples. We're going to simplify these expressions. Let's identify the like terms. Negative 3z and z. Over here I have 2.5x and 4.3x. And then I have positive 14, positive 8, and negative 5 over here. Okay, so I'm going to combine. I'm going to start, since I'm already in red, over here. In this case, it's 14 and then positive 8, so 14 plus 8, which gives me 22. And then I'm going to take my other terms, and I have negative 3z and plus z. Remember, if there's no coefficient, it's as if it's 1. So now we have negative 3. It's as if we have negative 3 plus 1. So those are different signs. We're going to subtract and keep the bigger sign. So our answer is going to be negative. And 3 minus 1 is 2. So it's negative 2z. And remember that 22 is positive. So when we combine, we get negative 2z plus 22. All right, next example, we're going to combine these two terms. They're both positive. So I'm just going to write it this way. That gives me 6.8x. And in this case, there's nothing to combine that negative 5 with, so I'm just going to bring it down, minus 5, and that is as far as we can go. All right, let's move on. One more example. The only thing we are taking into account here is anytime there's parentheses, we're going to do something called distributive property. You should also remember this from last year, but basically you might remember your teacher saying the bunny hop. I know I used that one, or rainbow, because you're going to multiply that number in front of those parentheses times everything inside. So in this case, when we break this down, it would be negative 1/2 times 6n, and then plus, so I'm going to put these in parentheses, negative 1/2 times 4, and then plus 2n. So we're going to have to break down those parentheses now, and we can turn these into whole numbers to make it easier. So negative 1/2 times 6n over 1. And remember, we can think of our rules. Same signs, positive. Different signs, negative. In this case, negative. 1 times 6 is 6n over 2. And then we're going to do the same thing here. Negative 1/2, but this time times 4. Remember, it's the same thing as 4 over 1. Once again, different signs, negative. So 4 times 1 is 4. 2 times 1 is 2. And then plus 2n is going to be at the end. So we're going to want to simplify these. 2 goes into 6n 3 times, so negative 3n. Let's see, minus 2, because negative 4 over 2 turns into negative 2, and plus 2n. Now we can combine and identify like terms. So in this case, we have negative 3n and positive 2n that we're going to combine. And remember, different signs, so we are going to subtract and keep the bigger sign. In this case, it's negative. So it would be negative 1n, or negative n, is what we would write in proper form, minus 2. And that is it. If you wrote negative 1n, that totally would be fine as well. But typically we don't see it like that. We just see it as the variable. All right, moving on to our very last example. We are going to apply this back to real life. So here's an example. Each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies. Interpret the expression. Okay, so it tells us each person in a group, but we don't know how many people that is, right? So an unknown value, just like you remember from the beginning of the notes, is represented with a variable. So over here, we have money values for each of the items we're going to get. So we're going to create an expression using those. So first of all, we know that each person in the group buys a ticket, so that means it's going to be $7.50 times, and you can use any variable you want. I'm just going to use x because that's probably the most common variable, plus also a medium drink, so those over here are $2.75. So 275x, because we don't know how many people. So the x represents, we're going to multiply that by how many people once we actually find that out, but right now we don't know. And then plus, let's see what else. A large popcorn, which would be $4. So 4x. Okay, so this would represent this because this represents a ticket, a medium drink, and a large popcorn, and the x next to it is telling us however many people we find out. Let's say in the group we get 8 RSVPs, then we know we multiply all of that by 8 in order to get that final total that we're going to all have to pay. Okay, so in this case we're going to combine like terms, so they're all like terms, they all have the variable x, so we can add 2 at a time if we want. So 750 plus 275 would give us 1025, and then we just add $4 to that, and that would give us 1425. Don't forget the x. So our simplified expression here would be 14.25x. All right, so let's do some examples of adding and subtracting linear expressions. This is actually the next section, but we have all the information from these notes to go ahead and do this. So it's the same thing, we're just combining like terms. They're just gonna look like separate linear expressions, but even though they're in parentheses, we know we can't combine those because you can't do x plus 3 since they're not like terms. So basically, you're just gonna add the like terms. So in this case, we have x and 2x, and then our other ones are 3 and negative 1. So we are going to do x plus 2x, and hopefully you know, remember we're just combining the coefficients. This would have the coefficient of 1. That would get us a total of 3x. And then we're going to combine 3 and negative 1, so 3 minus 1, which would give us 2. And our expression would become 3x plus 2. So the easiest mistake to make here is with the signs. So just make sure you are paying attention to the signs. And like this says, just as we did before, you'll combine like terms and add. But remember to distribute if you need to. In this case, we didn't. If there is a number, so if there was a number in front of parentheses or a negative sign. So this is where people make a lot of mistakes. And it's not on this example, but in a few examples, I will show you how people make that mistake. All right, so let's move on. All right, so we're going to add these linear expressions. So see here, since there's a 2 in front here, we have to distribute since it's in front of the parentheses. That's the first thing we're going to do. So remember the bunny hop, we're going to multiply it by each of those. So 2 times negative 5 would give us negative 10n. And then let me actually break this down so you can see what I'm doing also. So I would do 2 times negative 5n, and then plus 2 times 3. So 2 times negative 5 would give me negative 10. Remember, never positive and a negative are different signs. So that equals negative plus, and 2 times 3, of course, is just 6. And then we would add the rest that we have. So we had 4 minus n, and then minus 10n. And remember, you could add the plus if you wanted, but plus and negative is the same as minus, so I would just leave it. And we were going to identify like terms. So we have negative 10n and negative n. And in this case, we have 4 and positive 6. So here in the middle, we have same signs. And remember, anytime when we're adding or subtracting, the same signs, you're going to add and keep the sign. So negative n is the same as like negative 1n. So 1 plus 10 would give us negative 11n. And then we will combine the 4 and 6. And 4 plus 6, they're both positive, is going to get us positive 10. So what we end up with is negative 11n plus 10. All right, we have one last example. Here it is, and this is what I said was one of the biggest mistakes, is that people forget to distribute this minus. So what you want to do here is you need to distribute the minus to turn it into a plus. So it's as if we're timesing this by a negative and then this by a negative. So we have 5x plus 6 plus, and then negative times negative x, a negative times a negative, remember, gives us positive. So this turns into x, and then a negative times positive 6 would give us negative 6. So don't make the mistake of just canceling these, because remember that negative is being distributed to both values. So yes, you would do the minus times a minus equals a positive, but you also have to distribute that negative to the 6 to get us negative 6. So if it helps you, you can think about this as a negative 1 that you're distributing. And if you times negative 1 times negative x, you would get positive x. And if you times negative 1 times positive 6, you would get negative 6. And now you are in a position to combine like terms. We have 5x, and we have positive x. And then we have positive 6 and negative 6. So I'm going to combine these. They're both positive. Remember, x is like 1x. They're the same thing. So 5 plus 1 gives us 6x. And then we were left with positive 6 and negative 6, and that would give us 0. So you could write 6x plus 0, but of course that's just the same thing as 6x. And that would be your answer. And that brings us to the end of our notes, guys. So hopefully these help guide you, but we will be practicing a lot more in class, so don't worry if you're still lost. We're going to be working on these in the future. All right? So make sure you have all this written down. You can go back and rewind the video if you want to go over any extra examples. And I will see you in class tomorrow.